Hello, welcome back to Cracking the Cryptic on a day when the mercury is rising fast here in the UK. Apparently we might get up to 41 degrees Celsius, which is about 105 or something Fahrenheit. I mean, I know some people have it hotter, but we don't very often, so it's a bit alarming. I'm going to try and keep cool and do this puzzle. I mean, it would be a great day to do a thermometer puzzle, but I think Simon's actually done one of those, so I'm going to have a go at a German whispers puzzle. This has been sent in by Mormagli, who calls it Gossip Circle, and it is getting very good reviews. So could be interesting. Very interesting design of the grid. We'll get to the rules in a moment. Don't forget, oh yeah, Joseph Neymer's Equal Sum Lines competition is coming to a close in 2 days. So you have less than 2 days when this video comes out to finish it. We have had loads of correct results. Very well done to everybody who's done it. You set yourself a mission and you achieved it. That's very impressive. They're really good puzzles, and we thank Joseph dramatically for sending them. We also will be putting up a crossword video tomorrow as well. So my monthly Solve of the Times puzzle will be going up, I believe. Now, what else is going on? Well, you can check out the links under the video for Sven's SUDOKU PAD, all our apps, and the merchandise, such as it is. I mean, some of it is too hot to wear at the moment, but there are caps as well. I will be wearing my Bobbins cap on holiday this year. So do check it out. Now, this puzzle called Gossip Circle. Normal Sudoku rules apply. Digits next to each other along green lines must differ by at least 5. So those could be 1 and 6, for instance, but they couldn't be 1 and 5. Digits separated by a V must sum to 5. Not all possible V's are given. Really simple rule set, not many V's. Intriguing sort of grid-like structure to this, and do give it a try. You may be able to judge from the video length how hard it is. I'm hoping not to be here forever in this heat, but we will see. Let's get cracking. I'm going to restart the clock so I know how long it took. Okay, so. Well, obviously, when you get to German whispers, it's quite useful often to mark the grid with high and low cells. Now, in this context, high is above 5 and low is below 5. Now we don't know, we've got no given digits, we don't know anything about the high and low digits here, except I suppose on each of these square pieces there's 2 of each, because digits must alternate between high and low as you move along a line. That is just the nature of the difference of being 5 or more. Now I do know that any cell on a V is 1, 2, 3 or 4. So they're all definitely low, and I'm marking those in the hope that it inspires something, which it just doesn't. What on earth does that tell me, if anything? I suppose each of these 2 by 2 areas, they're going to be sort of Battenberg shaped, like they'll be high in one pair of diagonally opposed corners and low in the other. Even out here, that must work. But without knowing which is high and which is low, I don't know how that helps me. I suppose okay, up here we have 2 high and 2 low in this area. That's also low. So 3 low have been accounted for. So there's a maximum of 1 low in the top row there, and there are 2 lows here. So I don't know, that just means there's a minimum of 1 low in those 4 cells. I'm not sure what that does at all. Can we do anything with 5s? I think we can actually. 5s, they often turn out to be strangely helpful. 5s cannot appear on the green lines because they're never 5 away from another Sudoku digit. So let's, okay, what I'm going to do for now is very boringly, in fact, let's, I'm going to mark all those cells yellow because they can't contain 5s. Let's flash those with yellow as well. Nothing yellow can have a 5 in it. Now somewhere in column 1 there is a 5, obviously, that's the rules. And wherever there is, in the other 2 boxes, say there was a 5 there, just randomly, in the other 2 boxes there must be 5s in those dominoes. Oh, okay, then in this box 5 there would have to be a 5 in that domino, and no, not necessarily there. Yeah, that's why these corners, they're an escape for 5s, I reckon. There'd have to be a 5 here. So I've posited a 5 in row 2, column 1, and that suddenly gives me a 5 down here in box 8, which is weird. It would also give, oh bother. So if there was a 5 there, we'd have 5s in those dominoes, 5s not there, in that domino, and therefore there, also here. Oh, it's impossible because that can't be a 5. That is intriguing. Okay, so how can I generalize this finding? That can't be a 5, but it must be the same is true of this as well. Oh, well, that's brilliant. Yeah, this must work the same. If that was a 5, you'd have a 5 here, 5 here, 5 here, 5 here. Oh, now you can have a 5 in box 3. Oh, bother. Oh, that's so strange. Then you'd have a 5 here and 1 here and not there. Wow, there's a whole map of where the 5s would be if there is a 5 here. Well, is it really difficult in these corners? I think the corners are really difficult. If there's a 5 here, that's shoving 5s here and here, and here and here, and now there's nowhere in this box for a 5. Yeah, so I think that's got to work for all of boxes 1, 2, 4 and 5, it feels like. In that area, I don't think these top left corners can ever have a 5, because if you had a 5 there, it's pushing. Yeah, I mean, that's simple enough. That 5 pushes a 5 into that area, and now there's nowhere in box 1 for a 5. So none of these 4 corners can have 5s. I mean, that couldn't have anyway because of being blue. So we're down to 2 cells in box 1 for a 5. Now, can we rule one of them out? I wonder why they're different from each other, if they are. So we looked at that one and we saw it had an escape route there. What about this one? Ah, well, this definitely puts a 5 here. So whether there's a 5 there or there, we get a 5 here, and that's a 5. Wow, that's really a surprising finding. So now lots of things aren't 5s. Let's might as well keep marking them. Those aren't 5s. So there is a 5 in one of those places. Ah, this is an X-wing. One of those is a 5 and one of those is a 5 in row 5. And that's going to use up 2 5s in that pattern. So none of these are 5s now. Now it's getting interesting. Now there's definitely a 5 here. And that puts a 5 down here. There's no 5 in all of those. Now there's got to be a 5 in this cell. It is odd in these German whisper puzzles. You know, 5s, yes, they're the only thing you know anything about. Oh, look, in row 6 there's only one place. They're the only thing you know anything about, so you don't, but they do actually do stuff for you. Now, those aren't 5s. Ah, I think I might have run dry now. There must be a 5 in one of those positions, which is going to force the 5 in one of those. It's going to dovetail with the 5 there. We're left. Yeah, I don't know. I think that's it on 5s, irritatingly. I thought we might get a little further. But still, we've got 4 digits in the grid that I did not expect to get from an investigation into 5s. But now, and I mean, we've said this a million times, after you do 5s, what do you do next? You do 4s and 6s. So maybe I can do the same sort of thing and colour yellow. Oh, the trouble is, Well, okay, let's be as thorough as I can. These now can contain a 4 because they're a V, and that could be 4, 1. These on the edge of these ones could all contain a 4 or a 6, what I will call, not more planes, what I will call the inner digit. So I don't think well, maybe we can do the same sort of thing with the corners of these 4 boxes again. Is it the same situation with 4s and 6s up here? This is where the gossip circle is at these tables, I reckon. Yes, it is. Look, if you put a 4 or a 6 here, that's going to put a 4 or a 6 here. Let's talk about 4s randomly. If you put a 4 there, you get a 4 in that domino, a 4 in that domino, and there's nowhere for a 4 in box 5. And the same is true if you put a 4 there, that puts a 4 in that domino, and there's nowhere for a 4 in box 1. And the same will be true about boxes 4 and 6. So all of these corners are not possible. Now, I don't think that's going to work for these corners. If you put a 4 or a 6 here, you get 1 in there, oops, 1 in there. Oh, it does work, and that pushes 4 or 6 into conflicting places in column 4. So that can't be 4 or 6 either. This must be the same then. That creates 4s and 6s there. Yeah, that works as well. Can we take it here? I expect we can. That creates 4s and 6s there, which puts them up there. Yes, that one's impossible. This must be the same. Puts 4s and 6s there, which puts them both on column 4. Wow, okay, that's really strange. Now, is it only the corners, or can we extend that? See, if we do that in any of these cells, it's the same effect. Yeah. So they're all yellow. These two must be yellow, I reckon. Yeah, it's the same effect. It pushes 4s into there, or whatever digit it is, into there. So these yellows cannot be 4 or 6 so far. And there may be more, and I may be not understanding. Can we make these yellow? Because they, yes, we can. They push the same digit into those cells and therefore into those. So it's this powerful pattern in boxes 1, 2, 4, 5. It's acting all over the grid. I bet we can make these yellow. Yes, that creates 4, 6 patterns that we can't sustain up there. So now there is a 4 or a 6 in one of these dominoes, and there is a 4, the other one in columns is in those dominoes. I mean, it could easily turn out that this is a pointless exercise, but in which case, sincere apologies, but it's so interesting. This is such a weird pattern. Or it's not the pattern that's weird, it's how it operates. It does feel very unintuitive to me. Now, if you had a 4 there, you'd have to have a 4 in one of these cells. You'd have to have a 4 there, you'd have to have a 4 there. So it's going to work all around these dominoes in box 1, 2, 4, 5. But is that not telling me anything about the other boxes? I don't know if I bothered to explain. The reason that 4 and 6 can't be on these circular or square thermos is because any 4 you placed on it would have to have 9 on both sides, and obviously the two sides see each other. The same is true for 6, which would have to be flanked by 2 1s. It just can't happen. If I didn't explain that, it's a gap in the thinking, or a gap in the explanation, sorry. Now, come on, what is this telling us, if anything at all? It has to be... there has to be a 4 or a 6. Right. The colouring I've done, the yellow colouring I've done, acts for both 4s and 6s. And yet we have to fit a 4 and a 6 into, say, that column somewhere in there and into that row. Now, okay, what I'm learning from that is that at least one of these cells is 4 or 6. I don't think that's going to take me very far, but the only way that they wouldn't say both be 6s is if there's a 6 in that set and a 6 in that set. It would obviously be in the overlap. And then you couldn't do the same with 4s. So then one of these would have to be a 4 because that cell would be occupied by 6. But that's not necessarily entirely helpful. Now the population of these are 1, 2, 3, 7, 8, 9. That's why we've only been talking about 4s, 5s. Oh, bother, I went back and eliminated all my 5s. Oh, dummy head. Right, where did I have 5s? Oh, I don't want to do all the thinking again. I definitely had one here. I think I had one here and here. I'm just going to rewind to the point where I had the 5s in the grid, and then I'm going to restore them because I did that thinking. Oh. Hang on, what's happened here? The rewind button is not working. Nothing is working. Oh, this is a fiasco. What happened to the old software there? I must have hit something very unhelpful on the way. Okay, let's do the thinking again. I mean, this should be fairly quick at least. Right. Let's cover it off. 5s can't be on the green lines. That's just not allowed. So none of those can be a 5. Now, we worked out 5s can't be in the corners here. I think I've now worked out 5s couldn't be anywhere here or here or here or here because of what it would do to 5s in boxes 1, 2, 4 and 5. Therefore, there is a 5 in those cells. It's not on the V, it's there. That's a 5 as a result. There is a 5 in one of those cells, so there's a 5 there. That gives us a 5 there. And that's about where we got to, I reckon, with 5s. I mean, it also means all of these are yellow now for 5s, but let's not worry about that because let's do the 4-6 logic next again. Now for 4-6, most of these yellow cells stay the same, but not the ends of these lines. Right, so this is the anti-4-6 cells. 4 and 6 can go in the white cells, but not in the yellow. And this is a lot less helpful, isn't it? Because of these that are now available for 4 and 6, I think. Ah, and that's got a 5 in. So, oh, that's interesting. Now these have to be... Right, you need a 4 in this column in one of those cells, and you need a 4 in this row in one of those cells. Now, only one of those 4s can be in box 9, and the other one has to be on the end of the whisper line. And the same is true for 6s. So that must be a 4-6 pair. So this is a 1-9 pair. That's really weird. I don't know the heights or lownesses. At some point I'm going to hope to take out all the yellow and let's think about 6s. 6s can't be on the V's. Let's do them first then. So all of these cells are not 6s. So there's now a 6 in one of those two cells. Aha! There's a 1 next to it on the line, And now that's a 9, and that's a 4. That has to be 6, and that's a 1. The 4 in this row, it's actually, no. I've coloured that yellow because it can't be a 6. I cannot assume it can't be a 4. The 4 is in one of those cells, the 6 is in one of those in column 8. That means there's a 6 there. That means this is not 4 or 6. I don't know what I'm colouring now. I'm colouring for 6s now. That's what I'm doing. Let's keep going. Colouring specifically for 6s. They are all gone because we've got a 6 in that place. Is this going to help? Is this going to help? No, look, those can't be 6s because they'd have a 1 there. Yes, it is going to help. So the 6 in row 9 is there. That's not a 6. That can go yellow. Colouring for 6s. That's now a 5-6 pair. This is such a strange puzzle. I think I'm kind of stuck there. This pattern of possible 6s kind of remains. I'd love to put a 6 in there, but I don't think I can justify it. I'm not sure if I'm going to get any further. Maybe I am. Look, okay. Let's uncolour things that could be 4s. Can I do that, or do I have to start again? Well, that can't be a 4, but that could be. So that, well, indeed, where is 4 in this box? I think we established it can't be here by the original pattern. It can't now be there because you can't put a 9 on those cells. So I think 4 is there, and we get a 1 here. We've got a 1 there. We're going to need a 1 in one of those two cells. We're going to need a 4 in, well, now it can't. Oh, this has determined where the 4 is. There we go. It's there on the V. So that does sort out the 1. Wow, got some actual traction in this puzzle. Although I don't know what I'm marking for now. I uncolored that for 4s, but I don't think. Now, I don't think this, right, let's go back to where 4s could be. Yes, this was all about 6s. Now, I'm going to uncolour. Okay, I'm not going to do the colouring. Let's just think about where 4 can be here. It can't be in those cells because that pushes 4s. No, I am going to uncolour where 4s can be. I don't know what I'm doing, do I? Let's say that 4s can be, again, in all the white areas. Obviously, we've got those 3 4s, so those can go yellow. This can't be a 4. I think, okay, there's got to be a 4 somewhere in this box. Now, those can be 4s. That one can't be because it's doing the same forcing of problems. Yes, that can't be. And those can't be. And this can't be. So there is a 4 up here, which is fine because there is a 4 down here. And there is therefore a 9 next to it on its whisper line. These aren't 4s now. These aren't 4s and those aren't 4s. So now I've got a 4 X-wing in rows 5 and 2. That's genuine. Oh, well, actually, I could have seen that from columns 1 and 4 as well. That is a very clear X-wing. But unfortunately, it doesn't tell me where 4s are in these cells, as far as I can see. Right, what do we know, though, about this whisper line, which we've got 5 4 and we've got 6 1 on it? We know. No, I don't. I don't know which way round it goes. I don't know whether there's a 9 on it. Oh, look, 1 1. I get a 1 here. That's sort of interesting. That means there's a 1 on this whisper line. 1, 5, 6, 9, 4. Well, I couldn't put, I don't know, I couldn't put 3, 7 in there because they'd be touching. I don't know what to do with that. This is 2 or 3 because it's low. And it's not 1 or 4. Now, there's a 4 in one of those. There's a 1. No, I don't know that. There's a low digit in there, which is either a 1 there or a 2 or a 3. And then the same here, where there's a 1, 2 or 3 somewhere there. But I don't know which is which. What about this V? I haven't done anything with it. I'm missing some whisper relationship here. What am I missing about whispers? Or maybe let's go back to the original. I don't want to go back to the 5s. I mean, I know. No, I need to find something else basically at this point. Maybe there's something general about the whisper lines that I need to be thinking about. Or can I do more with 1s? Yeah, one of these boxes, only one of these boxes can have a 1 on. So one of them is not going to have a 1 on and is going to be made up of, is going to use 2 and 3 as its low digits if it doesn't have a 1 on. What does that mean? I don't know. Oh, come on, think. Now, earlier I was thinking that these couldn't be 9. Is there any sense in that? Yes, the high digit in those is a 6. Yes, the other one is a low digit because this must go low, high, or the other way around. So one of these is high and one is low. That's the Battenberg thing. So we've got a 6, 2, 3 triple there. Everything else in the column is 7, 8, or 9. That was true. It's funny how your brain does these things, doesn't explain what it's thinking. So these are from 1, 7, or 8, because they can't be 9 or 6. Now, if there's a 7 here, this has to go 7, 1, 2, 6. And that's 3, 8, 9. Now, what does that do? I don't know. There is a 1 there. Oh, I don't understand. I don't understand how I can make progress. There must be a way, obviously. What is it? This can't be a 4. Does this X-wing stop that being a 4 and make that not a 1? Which might be interesting. Can this be 4, 1? Can it be 2, 3? And the answer is no. There's a good question. Can it be 2, 3? The answer is no, because you can't put both 2 and 3 in here. Only one of them will be in those cells with a 6. So that is a 4, 1 pair. That one can't be the 4 because of the X-wing we've got, say. So that is a 1, and that's a 4. And that fixes the X-wing. We get a 4 there, no 4 there. We get a 4 here. That puts 9 on this whisper. Might get rid of all the yellow in a moment because I don't know that it's doing me any good. Yeah, I'm going to do it now. Going to risk clearing the yellow. There we go. Now, how are we doing for 4s? We've just got 1 to go there and 1 to go there. What has that done for 5s? Has it done anything for 5s? Oh, this 1. That puts a 1 on this whisper. That means there's no 2 or 3 here. Oh, that means this whisper has no 1 on and has 2 and 3 on, therefore. There are its low digits. This whisper has 1 of 2 or 3 on, so one of these digits is a 2 or a 3. Now maybe now I've got rid of the yellow colouring. Let's start colouring for low and high just to see if I've missed anything about that. So these are definitely low. 9s and 6s are definitely high, as is a 7-8 area. Right, and we can carry on the colouring on the ones where we've got started on the whispers there. Now, is that going to tell us anything? It tells us this is 7 or 8. This is 2 or 3, and there's one of each of those in column 1. This is high, but could be anything apart from 6. Oh, frustrating. Come on, think again, think again. So all the V's are done now, but what helped was thinking about that not being 2, 3. Is there a lesson in that somehow? 1 is on this whisper as well. It just doesn't add anything, unfortunately. 9, 1, 6, 5, 4, so 2, 3, 8, 7. Right, this is 2 orange and 2 blue. That's orange, that's blue. Here we have 1 orange and 1 blue. Let's paint them stripy. Here, 2 of each. Blue, blue. There we have a definite orange and a white 5. So here we have an orange and a blue as well. So that's 3 blues already up column 1. Ah, there's 2 blues here. It doesn't mean there has to be a blue. Could those really be 3 oranges? I suppose they could. No, actually no. Can't have 2 blues here because one of them needs to be on this whisper with the 1. So there's at least 1 blue. Is that right? No, it's not right. It means there is only a maximum of 1 blue up here. I don't even know if this is a sensible thing to be thinking about at all at this point. But it might be. It might be. Let's keep going. 2 blues, 2 oranges there. So 2 of each in these cells. 3 blues needed here, but only a maximum of 2. No, I don't know. This isn't going anywhere. Ah, 2 and 3 are here. 7 can't be on that anymore because it would be next to 2 and 3. Okay, so is it really time to colour cells that can't be 7? Seven can only be on one of these squares if it's with 1 and 2. And yet surely 7 has to be on some of them. It's interesting. 7 can't be there. So if 7 is up here, it must be in one of these two. And then 2 must be there. Ah, that's getting interesting in a way. I wish I knew more about 7. Oh, so strange. Well, maybe I know more about 6 than I've realised. Maybe I should go back to thinking about 6. I've got a pair there. There's got to be 1 amongst those 3 cells. Maybe 6 always had to stay away from 4 in some way because of this. Don't think so. Well, okay, but let's go back to some of the cells that couldn't be 6. Those yellows couldn't be 6. 6 can never be on these. Now that was all true. Now none of these can be 6, obviously, because there's 6s in these boxes already. That's not a 6. So there's 1 6 somewhere in row 1 and 1 in row 4. There's 1 in column 4. There's 1 in column 1. I can't hear you, Maverick. Now maybe it's about whether there's room for 5s and 6s. I mean, I sort of know by uniqueness that's not a 5-6 pair, but that's not a relevant consideration. So 6s could go in the white cells. If there's a 6 there, there's a 6 there, there's a 6 there, there's a 6 there. The trouble is that round boxes 1, 2, 4, 5, they just rotate around these positions. They don't fix anything. So maybe I do still have to think about 7s and the fact that one of those is a 7. It might be this. It might be what 7 is doing to 2. That's so weird. It feels like that joke about 7, 8, 9. But I think 7 is having an impact on 2 here. So these are from 2, 3, 7 and 8, these cells. I gave up on the high-low thing, didn't I? I did a bit. I don't see how it could help. Oh, look, these are all either high or 5. Maybe I should have kept going a bit. 1 high, another high. We need 4 high. So either that's high and this is high and 5, or they're both high and this is 5. If that's 5, oh, it doesn't work, look. It's because this can't be 5. And that's 4. There's a 5 up here. It's that simple. How long does it take? That gives me the 5 in column 1, the 5 in row 1, the 5 in box 5, and leaves an X-wing there. Just as I've got an X-wing of 4s, I've got an X-wing of 5s. Right, now what has that done for 6s? One of those is a 6 because only one of those has a 6. So one of those is a 6. That's not a 6. There is a 6 here. That's something it does for 6s. Let's colour it orange. Come on, this is helpful. And I should have spotted that about 5s ages ago. Now, am I colouring for 6s now? I think I am. The yellows are non-6s. So I can also colour all of these. Yes, 6 in this box is now here. Let's actually do that colouring. They're yellow, that's yellow. 6 in the middle box is there. That's fixing the 4 X-wing. We get a 6 here as well. That puts a 6 up here, and 6 in on the whisper finally. No, hang on, let's do that one first. Then go to the whisper. That does our last 5 as well. Then we go to the whisper and we put a 6 here next to a 1, which is next to 7 or 8, which is next to 2 or 3. Right, come on, this must have done something. Let's get rid of all the yellow colouring now. Because have we done all 4s, 5s and 6s in the grid? We have, and a lot of 1s, but not all of them. Right, there's no 1 there though, there's a 1 here. Okay, and 2 and 3 are here. That's high now. It's too high, that's high. That's all high. This is low in the corner, 2 or 3. Now we've got all the 4 lows here, so those are both high. Seven can't be there, so it's here. These aren't 7s. This is 2, 3, 8, 9 now, in some disposition. 6, 4, this is, I don't know, 7, 8 or 9. Where's 6 in this column? There, I just haven't coloured it, or that one, and I haven't coloured these 4s, or that one blue, that's also orange, right. This, we know its colour, obviously it's blue, that's orange. Oh, literally cannot sweep up numbers. That's a Battenberg of 2, 3, 8, 9, 6. Now 7 could be on here, but only if that was a 3 to keep 7 away from 3. 7 has to be kept away from 3. That is the big deal that's going on here. How can we leverage it? It's a really interesting puzzle. I mean, I have to say, this has made me think about things in a totally new way. Right, if that was a 7, 7 would have to be on here with 2. What does that mean? Don't know. I suspect it's telling me that there's a 3 down here. No, a 3 here. But I can't quite see how. Oh, 9 in this row? Oh, it's got there or there. And if you keep 9 off these wheels, one of the wheels has no 9. And therefore, the highest digits it can have are 8 and 7. And then it can't have a 3. So, whichever one doesn't have a 9, is that right? Also doesn't have a 3. Such a weird relationship. I think it's true. Whichever one of these... Oh look, 9 is looking at all of those cells. The 9 in this box is in one of those 2 places. So let's keep thinking about that. Whichever one of these 2 doesn't have a 9, also doesn't have a 3. So 9 is going to appear either here or here. And in either case, it's going to put 3 in one of those 2 places. So strange, but I think it is right. Trouble is, I don't know how to use it at all. 3 in one of those places. I mean, it would mean this couldn't be 3, but I'm not desperately trying to make it 3. 6, 9, 4, 2, 3, 7, 8. That's not a 7, but the trouble is that can be, which does keep 7 off this. Now, this is 2, 3, 8, 9. That uses a 2 and a 3. This can only use one of 2 or 3. Right, I'm asking where do the 2s and 3s go in columns 6 and 7? 2 of them can go there. Only one of them can go here because there's a 1 is already a low digit there. The only other place for the 4th 2 or 3 is here. So that is blue. And I could have done that by counting this column and giving 1 each there. Why don't I see it normally, ever? Right, 4, 1, 6, 5, 1, 2, 3. So, 1 more blue and 2 orange amongst these 3 cells. Oh, no, I don't. One of those is blue and one is orange, and I don't know which way round they are. 2 blue, 2 orange in those. So one of those is blue, one is orange. That forms a kind of quadrilateral, a trapezium, or a parallelogram or something with that. And they alternate in terms of blueness and orangeness. Now, I know what this is because there's 2 blue and 2 orange here, 2 orange here. That's blue. 2 or 3 again. I could have done that in that column. Honestly, I just can't see ordinary things. Now, one of these has a 7 on it. If that has a 7 on it, that's 3, because 7 can't be next to 3. If that has a 7 on it, that's 3. So one of those, at least, is a 3. They're both seeing those cells, which can't be 3s. We've worked out the same for these 2 cells. One has to be a 3. So that can't be a 3. If those can't be a 3 because one of those is a 3, then 3 in this column, which also I've worked out can't be there, is in one of those 2 cells. If only that helped at all. Seven, no, it doesn't have to be there. I really do want to place 7 on a whisper somewhere because it's going to really help with the 2s and 3s. Right, either 7 is here with a 1, and then 2 has to be here. That's really weird. Either 7 is here with a 1, in which case 2 has to be here, so 2 is here, and that becomes a 3. Or 7 is not there, and it's there, and then that becomes a 2. I suppose it's not that weird, it just feels it. It really does. Oh, I'm 1 step away here. Literally, definitely 1 step away. What is the secret to this? Right, if that was a 3, which is one of the 2 possibilities here, if that was a 3, it would have 8, 9 either side of it, and a 1 there. 3, 8, 5, 1, 6, 9, 2, 7. That would put a 2 here. I don't know, they can't both have a 7 on. Or can they? Maybe they could. But then they'd both have to have a 1 and 2 on. And that would be a 1, 2, 7 triple. Wow, coming up to the hour now. I know I'm only 1 breakthrough away, but I don't know what that breakthrough is. There's only 1 blue and 2 oranges here. Therefore, this is 1 of each. I've known that forever. I've got that trapezium, haven't I? Blue, orange, rotating around it. 4, 4, 5. There's something, there must be something just basic. 9 in one of those 2 cells. If that was a 9, that would be a 9. We'd have a 9 there, 9 there. Let's just see what happens. Have to have a 9 there at this point. Got one there. And that runs out. It's perfectly feasible. Now, the alternative is 9 there, 9 there. I think this is less powerful. We'd have a 9. I don't see what that does. No, it's not about 9s. That can't be 2-7. I mean, it can't be 3-7. So it uses either 2 or 8. The same's true here. It uses either 2 or 8. And therefore this uses either 3, well, if you use 2 there, then you use 8. No, that's not necessarily true. It doesn't have to be 2, 8. If you use 3 there, you use 8. Oh, what? It's just this 7 is placing this as a 7. How long can it take? I'm sorry, that has been painful for you guys. That fixes that as a 2. That fixes that as a 3. I think we're away now. That stops this being a 3. It places 3 here. This isn't 3 now. I'm so apologetic about that. 3, 8, 9 is a triple up there. That's a 2. This now has a 3 on it, so it can't have a 7 on it. So it's 1, 3, 8, 9. That's 7. Yeah, this is how it works. Well, I mean, maybe it was valuable to understand how this worked before doing it, but honestly, it would have been more fun to understand it while doing it. But I claimed earlier on that I was 1 jump away, and let's see if that was true. This has become a 7, so that can't be a 3. This is now a 3-8 pair. That becomes a 9. This is 2, 7, or 8. Don't know enough about that yet. I haven't found out what polarity that is. So now we get to the point where I have to put up or shut up. But I never shut up, as you know, so that might not work. Now, this is 1, 2, 7, 8. Right, the 2, 7 pair go in these cells. The 1, 8 pair go on this side. That's a 3, 9 pair. This is a 1, 8 pair. We can do the 1, 8 thanks to that 1, 8, 1, 9, 3. That's not 3, 8. That's not 2, 9. These 1, 8, 2, 7, no, they're not resolved across the board. 3, 8, 9 up here, no, 2, 9, 3, 8. Right, what do we know here? We know that we need a 7 in this column. This is annoying. If I am stuck again, very annoying. 3, 7, and 8 still to place in that row. 4, 7, 5, 6, 1. That can't be a 7 anymore. So 7 is in one of these 2 cells. That means these aren't, they're not 7s. That's a 2, 8 pair. That gives me a 7 here. It also means 7 is on this wheel, and therefore 3 isn't. So now 3 is here. That is useful. Okay, so this is a nice high digit. 5, 3. We got that 7. That's not a 7. The 7 in this row might be there. 1, 4, 6, 5, 3. 2, 7, 8, 9 still to go. Come on, let's keep going. We're getting there. We are getting there now. I do think this is unwinding from where we got it to. Right, 8 or 9 is there, and 8 or 9 is there. That's using them both up. So this has a 7 on. That's its high digit with a 2 clearly there. And that makes this an 8, and that makes this a 2. That makes this an 8. If I could type it, it would. Now the 8 has fixed 1, 8, so we know the way that whisper line works. That fixes 2, 7, so it places the 1. This is a 9. That fixes to 9. We can go round the whisper wheel, or the gossip circle as it's called in the puzzle title. This becomes an 8. That's a 9. Oh dear, this has not been a good solve, and it shouldn't have taken this long, but my goodness, I am relieved to be getting there. 2, 3, 7 to fix down here. That's 2 or 7 as well. What's this? 4, 7, 5, 2 or 9. So this is done. It's in an I-wing. That's an 8. 7, 2, 9, 7, 3, 2. Oh my goodness, what a puzzle. There we go. Good. Well, as you saw, I struggled with that, but I am pleased to get through. I mean, I think it's difficult. I'm not going to say it's not a difficult puzzle. It is. And it's very impressive. Well done, Mormagli. How about that? But my goodness, that's a strain. Oh, let's fix the partly coloured cells. So those aren't orange anymore. Those aren't blue. Is that everything, or have I left anything half coloured? I think that's the correct colouring as well. Thank you for watching. That has been an epic journey. And I've enjoyed it, although not my own slownesses, particularly with that 7 that was so placeable up there. But there we go. That's what happens sometimes when you're solving live, trying to explain it as you go. I don't feel sorry for myself, so yeah. Thanks for watching as always. Hope to see you again soon on the channel. Bye for now.